Dale, today we're going to start talking about more polygons. So we've talked about triangles a bunch this year, and we're going to talk about some different polygons. So the first thing we need to be able to decipher is whether a polygon is convex or concave. And so the simplest way to compare them would be that all the vertices of the convex polygon point outwards. So all the places where two segments meet sort of point outwards. In a concave polygon, we have one or more uh, vertices that point inwards. So you can see the place where these two segments meet points inwards, sort of like a dented polygon. And so those ones are called concave. The ones that stick out are called convex. We're going to speak mostly about convex, but you need to be able to tell the difference. So I want you to take a second, pause here, and classify each of these polygons as either concave or convex. So this first polygon, I have that vertex that points inwards, and so that is a concave polygon. In this one, it's a slight dent right there. Those two segments meet, and the vertex points inwards to the inside of the polygon, and so that one's also concave. And in this last one, all the places where the segments meet, all the vertices point outwards, and so that is a convex polygon. And so when we have either a concave or a convex polygon, we can name them specifically by the number of sides that they have. And it's important to note that a polygon will have the same number of angles as it does sides. And so you know that a three-sided polygon is a triangle, four-sided is a quadrilateral, 5 is a pentagon, 6 a hexagon, so on and so forth here. These are the ones that you'll need to know the names of, and you'll need to know if I tell you how many sides it has, what its name is. If I tell you what its name is, you'll need to know how many sides it has. Most of these are ones that you're familiar with. Maybe a dodecagon, a 12-sided polygon is new to you. Once we get past 12 sides, we don't have specific names for them. So n represents the number of sides in a polygon. So any polygon that has sides more than 12, we just plug that number in and put gon at the end. So let's say I have a polygon with 14 sides. We would call that polygon a 14-gon. And so if I see something about a 14-gon, we're just talking about a polygon that has 14 sides. So make sure you get these names down. Make sure you know these names because you're going to have to. Now, one of the most important things we talk about in polygons are their angles. And so we're going to start talking specifically about convex polygons, the ones whose vertices always point out. And they have interior angles. The angles that are inside those lines are interior angles, but we can also create what are called exterior angles. And that takes a little bit of imagination. It's if I were to extend this side of the polygon straight out, I would create an angle right here that's outside of the polygon. And that's called an exterior angle. And so if we did that for every side of this polygon, and we measured those angles would always, 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 always add up to 360 degrees. It doesn't matter how many sides that polygon has, they're always going to add up to 360. So if I draw the exterior angle for every side in a convex polygon and I add all those angle measures up, they'll always add up to 360. And we call that the sum of the exterior angles, which sometimes we abbreviate as SEA. The sum of the interior angles is a little different. We call that SIA, and we have this formula for that. I said on the last page that n represents the number of sides in a polygon. And so if we want to find the sum of the interior angles of any convex polygon, we can use this formula. We take 180 and we multiply that by the number of sides minus 2. And so here I have a 7-sided polygon. It's a heptagon. The exterior angles add up to 360. And if I want to find out some of the interior angles, I plug the number of sides 7 into my formula. And I find out that if I were to measure all these inside angles, use a protractor, measure them all, add them all together, they will add to 900 degrees. So let's do another one of those together. We're going to name this polygon, and then we're going to say the sum of the exterior angles and the sum of the interior angles. When I'm counting sides, sometimes it's really easy to lose track of which sides I've counted, so I sort of put like a mark on one of them, and that's the first side I count, and then I go around clockwise. So I have 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. If I were to draw all the exterior angles, measure them with a protractor, add all those angles up, the exterior angles are going to add up to 360. To find out what would happen if I measured all the interior angles and added them all up, I plug into my formula. I have 6 sides, so I plug 6 in for n, and I find out that in a hexagon, the sum of the interior angles is 720. So just like you should know that the sum of the interior angles of a triangle is always 180, you can start remembering the sum of the interior angles of these other polygons. And sometimes that's helpful because any 6-sided convex polygon is going to have 720 degrees in the interior angles. So any other hexagon you look at, if you were to do this formula, you'd get the same answer. I want you to pause, and I want you to try this one. I want you to name this polygon by its number of sides. I want you to tell me the sum of the exterior angles and then the sum of the interior angles. So again, it's easy to lose track, so I'll put a mark on the first side I count. 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon. It's not the octagon that you're used to seeing, but it has 8 sides, so it's an octagon. If I drew all the exterior angles, measured them all, added them up, the sum of those exterior angles would be 360 degrees, as always. I use my formula to find out how much the inside angles or the interior angles add up to. I plug 8 in for n because this has 8 sides. And I find out that if I were to add all those inside angles, every single one of these 8 angles inside, I add them up, I get 1080 degrees. So I have one for you to try, just like we've done the last 3. Name this polygon by the number of sides, tell me the sum of the exterior angles, and tell me the sum of the interior angles like we did on the last 3. And if you have questions, please be ready to ask them in class.